Hey guys, Overhaul1 here. Welcome back to another video, and today you're going to watch me be more careful with this locomotive than I have ever been or will ever be with any other engine, because this is my dad's Lionel 6-38056 Pennsylvania Railroad 482 Class M1a mountain-type locomotive equipped with Trainmaster Command Control. This thing makes me want to have good lighting. I don't, so oh well, I guess. But yeah, this engine means so much to me. And if you saw my third rail M1a video, this is the engine I'm talking about. The one that's going over the bridge, and I have the picture of me with my hands on the transformer watching it go over on his layout, and the one I remember seeing on a display track for most of my childhood. But it's that sitting on a display track that I think has caused a couple of the problems here. These old engines really need to be run. They don't do well when they just sit. So this engine has sat for most of its life. It's really only been run a handful of times, and every time it does run, there's always some new challenge that we have to overcome, and I'm here with it today because we went to go run it on the club layout when my parents came up to visit me the other day, and it basically threw a fit. The entire time it was just throwing a temper tantrum. So yeah, we need to fix some problems here. The first one that we need to fix is the smoke unit isn't nearly as powerful as either me nor my dad remember it, nor is it as powerful as any of the fan-driven smoke units from this era that I've worked on recently. And then there's a huge problem with motor control. I'm pretty sure it has something to do with the IR connection going between the locomotive and the tender. They don't talk to each other right, and the engine will spaz out, the headlight flickers, the motor stutters and shakes, and the whole engine sort of just tries to rattle itself to pieces until it finally just says, screw it, whatever, I'm just going to run now, I guess. And then it works just fine for a little bit, and then it eventually dies again. But I want to fix that. So yeah, I'm going to be really, really careful with this thing, and I'm going to try to fix the problems that have plagued this engine since, well, as long as I can remember. Oh yeah, it also needs a traction tire. Anyway, let's power this thing up. Exhibit A. Let's, I saw a spark here, and I don't like that. So let's play with this a little bit. Make sure that that's not grounded out on anything, and try this again. The command base is on. It should be booting in TMCC. There we go. You can see the headlight freaking out. If I do engine 67, nope, it's definitely 67 though. Okay, let's power it down. At least it's like in TMCC mode now. Yeah, what? Okay, let's try this again. Let's play some more with the IR tether. It's weird, it's like waiting for a signal. But not doing anything about it. Okay. Well, let's try this. Huh, okay. Yeah, so remember when I said this engine's really temperamental and it just kind of throws a fit? This is what I'm talking about. I really can't think of a better way to illustrate what I'm talking about here than just it doing this while I'm trying to demo its problems. But I guess these aren't the problems. So it's doing its job, I guess. But yeah, this is what we're going to try to fix today. Yeah, I get the feeling this is going to be a fight. Also, if you're wondering why I unhooked the tender, all of the electronics, so this thing weighs a ton. All the electronics to run the engine in TMCC are actually in the locomotive. It's got the DCDR board, it's got the R2LC in it, it's like all of that's in here. The only thing that's in the tender, other than what feels like, a box of lead, is the rail sounds. So the speakers, the sound cards, the rail sounds power supply. Yeah, we will get into this at some point, I'm sure. But for right now, I really just want to make the engine run consistently. So we're going to start up front. So over the years, we've done a bunch of different things to try to make this thing run. Also, you can really see how green the Brunswick is on this thing in that angle. Anyway, yeah, we've done a bunch of different stuff, including loosening up these screws and running it with them loose. We've done stuff with the antenna. I've messed around with the actual internals of this thing. I've never done it when I have my full kit of tools with me, so that's why it's here, and I'm not going home to work on this. So yeah, let's get started on this. So 2 screws in the back. And now sometimes that actually does just fix the problem on its own, but I don't like that that's the solution, so it'll just stay there for right now, I guess. I want to get a better sense of why it's doing what it's doing. And there's a single screw up front, so I gotta take the pilot truck off without, destroying all the paint and everything. You'd think I'd be better at taking this engine apart, but honestly, I haven't taken this thing apart too much. Usually I try not to mess with this thing because, it means a lot to me, and if I would screw it up in any way, I'd be really upset. But it has problems that need to be fixed, so here, this is what we're doing. Okay. Let's get these connectors unhooked here. These are the antennas. These are the front markers and class lights. And then the cab light just goes into a grommet, which is interesting. But yeah, so that's the only thing left here is the antenna. Now, I've got a suspicion that the antenna's grounding out somewhere. Where it's grounding out, I've got no idea. But over the years, I've found that messing with the antenna a little bit can sometimes get it to actually, do its thing. But let's fire up the frame and see what it does. Okay. Honestly, the fan in the smoke unit has not given us any problems. I think it's just the heating element right now that's giving me an issue, but let's see if this actually runs. Oh yeah, there we go. So it's not smooth by any means, but I think I know why that is from a previous diagnosis that I did on this. But yeah, I'm gonna fix the motor first, and then the antenna, figure out why that's not behaving, and then the smoke unit. So on the Odyssey engines, anything with Odyssey 1, there's a revamped Odyssey that isn't Odyssey 2, but they both use this magnet wheel. And what's happening here is the magnet wheel has alternating polarities as you go around, and they are picked up by a Hall effect sensor on this sensor plate here. And as the polarity of the magnet flips back and forth, it turns on and off the Hall effect sensor, and that's what provides the closed loop motor feedback for the for the DCDR, which is the motor controller in the engine. So that magnet wheel right now has a big old crack in it, which, you know, obviously is not great. So I'm gonna try to take off some of these electronics so I can get to that, pop off the magnet wheel, and I think I have replacements for it, so I should just be able to slide a new one on. The amount of dust in this thing is amusing. But in order to get to where I am now, I had to remove the rear two screws that hold on the DCDR, and then I've removed the screws that hold on the bracket that holds on the motherboard. And now I can finally get to the motor plate so that I can pull this up so I can slide the U-joint off so that I can pop the magnet ring down and off and I can put on the new one. I do just have spares. I bought these at some point. But yeah, I got two of them, so if I mess it up once, I'm okay. But yeah, let's keep going here. One of the really cool things about this is that, like, because this really hasn't been touched much, a lot of these screws still have factory torque applied. So like when you break it loose, it gets a nice crack. It's very nice. It's very satisfying. So if I remove this plate, that is a huge worm gear. Holy smokes. And now I should be able to take my pliers and this should just come out of the gearbox. Why does it not? There we go. You know what I'm just now realizing would probably be a hell of a lot easier? What if I just took the motor off? Why am I going about it this way? I'm pretty sure the motor is just 3 screws on the bottom. Nope, it's not. Okay. There's no way the motor mount screws are under the motor. That would be ridiculous. There's no way to install it. Oh, no, the motor mount's up here. Right. Not a brass engine. Okay. Motor mount's there. Screws are, in fact, on the bottom. Yeah, that's probably way easier. I'm just going to go do that instead. Okay. Rear truck. Single screw, I think. Okay. And then there are 3 screws that hold on the motor mount that are all factory torque, which is fantastic. Okay. 1, 2, 3. Sweet. And then this should now just come up. And it can't go backwards because there's a firebox flicker in the way. So let's take that out. Okay. And now, in theory, I should be able to just slide the motor back. In theory. Okay, I got the dog bone out. This is the dog bone. This is what connects the two, or the what do you call it? The output shaft of the motor to the input shaft of the gearbox. And that should free up this to rotate a lot more easily. Nice. Okay. Here's our old magnet ring with a crack in it. And let's grab our new one. Make sure it does not have a crack in it. Does not appear to. And slip that on, and that is way too loose of a fit for my liking. Okay, I'm gonna put a little bit of super glue on this to prevent this from sliding around. But I'm going to need to try to score the inside of this without cracking it, and I'm going to need to score the the what do you call this cone piece. So yeah, let me do that real quick, and I will get back to you when this is glued back on. So I started reattaching stuff and it was still causing problems, so I just said screw it, and I put a jumper between ground and the frame of the DCDR, because I forgot that these engines need to be basically fully reassembled in order for them to have like all the proper ground hookups and everything for the electronics to work. So I still have no cab light, but I do have power. So if I start trying to roll the motor out without, rubbing it up against everything. That's really fast. So that to me says the ring's not close enough. So let me move that closer and see if it figures. Or I have it backwards, which wouldn't be good either. I took a look at the old footage and I do think I just had it backwards. There are these dots on the ring. They're only on one side, and I believe they point out. I had them pointing in. So let's see what this does here. Oh yeah, way better. I can feel it twitching a little bit. Huh. So I think what you guys just witnessed is my transformer just blew up. That's why everything just shut off. It's plugged in right now. I've got no light. I've tried unplugging it, giving it like a couple minutes to just sit, plugging it back in. Power cycling it does nothing. I checked to see if there's a direct short on the rails, and there isn't. I think the transformer literally just blew up. Like, I have no explanation for what happened. I don't feel it like humming or vibrating or anything. The only real sense of anything that I had was like, I could feel the motor twitching, and I heard like this growing hum in the background that like, it didn't sound like something was shorting. It just sounded like something wasn't right, which is why I started to get suspicious, and then everything stopped and it's like, wait a minute. So yeah, interesting. So I may have to run to the storage unit tomorrow and grab my other controller, my other transformer. I don't know why this one would just die like that. I want to try to take it apart, but I'm fairly certain it has like triangular safety screws in the bottom of it to prevent you from doing that. Not saying that that can stop me, but it is a little bit more difficult, and I don't have the tools on me to do it. So yeah, I don't really know what that was about. I really hope it didn't take the locomotive with it. That would be really unfortunate. Yeah, so I guess I'm kind of done right now until I get my other transformer. So I guess to sum up for tonight, I did go, while I was waiting for the capacitors or whatever in the transformer to de-energize, I did go around the magnet ring and make sure that it was perfectly flat to the sensor. It wasn't perfect the first time, and basing that on my Reading G3 that I put Legacy in, maybe that had something to do with it, but this is using magnets, so it's a lot less sensitive. So you saw that on speed step 1, it kind of stuttered a little bit before it found its rhythm. I'm hoping that was just, it trying to find its bearings. But then it was running fine until the transformer, I'm assuming, just failed internally. So yeah, now that this is a little bit more square, hopefully that fixed any problems that has. I'm going to grab my other transformer tomorrow and pray that the rest of it still works, because yeah, I don't know what that was about. It didn't like pop the surge strip that I'm plugged into or the breaker. The TMCC power base or the TMCC command base was still on and fine. I just lost track power. Yeah, I have no idea, but maybe that'll be a future video when I go ahead and dissect that thing and figure out what exactly happened to it. But yeah, that's gonna do it for tonight. So I will see you guys whenever I have time to work on this again. Hopefully tomorrow. Okay, we're gonna do a brief aside. I'm gonna fix this. It's now the end of the week. It's actually Friday. The last shot was on Sunday, I think. I had to go and get triangular headed screws. I got these off Amazon, just in this kit. And these are the three, I'm guessing 3mm triangular heads, and that's what the screws in the bottom of the CW80 are. And when I opened it up, I found this. Yeah, so big old transformer, control board up top, there's the potentiometer for the power handle, and then this is usually wrapped in shrink wrap. I just cut it out. I also just broke the solder off of it, so that's fun. This is a 5-amp slow blow fuse, and if you can't tell, that ain't doing the fuse thing anymore. That is totally blown. So, not entirely sure what this is protecting. I would guess the control board, but from what I've read, the control board can... I just realized that there's a plug up on the control board to go from the transformer to the board. That's nice. But yeah, sometimes the board gets fried when this happens, so if it is in there to protect that board, it does a pretty crap job of it. Hopefully mine's still intact, because they don't always go, and other times the potentiometer fails. So, gonna hope that all of that's fine. I just need to replace this fuse. So what I did was I went to the auto parts store and I got a like an inline fuse holder and some 5-amp fuses. And I'm just going to slap that in here, and if you have actual like normal screws instead of these triangular headed security screws, use those instead of this so that you don't have to, if you ever lose this tool, you're not just completely screwed. I'm going to be putting the triangular ones back in it because I don't lose my tools usually, and I don't have screws that are not the triangular ones that fit into these holes. Also, yeah, these are a pain in the ass to get out. If you can't tell, I had to take a pair of pliers and clamp them onto the edge and use them as a handle to break these things loose. I swear they're not only tightened to like, I don't even know, it feels like 100 foot-pounds, but they're also like, it feels like they're Loctited in. So, yeah, pain in the neck. Do not try and go at this with tools that are not intended to do this, because you will just strip it, and then good luck. You're going to be drilling it out at that point. So, that is always an option too. If you don't want to get one of these tools and you have a drill, just drill it out. And then, find some other way of just holding it together. But, anywho, let me go unsolder the other half of this, and add in this fuse thing, and, we'll fire this up and see if it works. There we go. Now we got a 5-amp automotive fuse instead of the blown 5-amp slow blow. Also, I really hope this is actually 5 amps, because if I plug this in and this immediately blows, either I've got a bad transformer or the fuse is just the wrong size. From what I was researching, it's supposed to be 5 amp. So let's plug this in. I'm going to take the mountain class off the track so I don't, fry that somehow. Let's plug this in. We'll power it up. I'll use my multimeter, see if it's actually getting track voltage. And, yeah, we'll go from there. Okay, let's plug this in and see if I blow a breaker or something. Oh, the light's on. That's good. Okay, let's go to AC voltage. Please work. Hey. I mean, it's not graceful by any means. That's kind of interesting that it can either be 0 or it can be like 5. I guess I've never really like looked at the output from a CW80. But seems to be doing the thing, so I guess I'll plug it back into the track and make sure it doesn't blow the fuse again, and then I'll probably find a different engine to test it with before I test it with the mountain class. Alright, this seems on theme. I don't really have any engines here that I don't care much for, so like, I care about everything that's here, so we're just gonna hope that this works. Okay, cool. Yep, alright, sweet.
This is Vinci 5848. Can I pull? Over. Roger, 5848. Take the green. Over. Thanks, dispatch. 5848 here. Train is clear to move.
I know the radios make no sense, but I think it's so cool that it actually has like the road name and road number specific dialogue. That's now a Vision Line only feature because that's exclusive. And yet pretty much every TMCC / early legacy engine has it. But whatever. I digress. Okay, back to this again. I'm going to keep the transformer in shot and over here so that maybe you guys can see it if it decides it wants to freak out. But okay. Engine 67. Alright, let's see if it rolls out. Sure does. It's got that good old Odyssey 1 motor just kind of twitches a ton until it kind of figures out what the hell it's doing. Very quiet, though. Also, if anybody can tell me what, like, the beeping sound is that comes from these engines, like, as they're just existing, please do, because I've always been really interested in that. It's not like the smoke unit. It's probably something to do with, like, the R2LC, or the DCDR. But, yeah, I always found that interesting. I'm also just realizing maybe that cab light might be out, that or it's just not grounded. Feels like it's pretty consistent. I guess I need to check if the chuff is chuffing. Oh, no, wait a minute. Right. It's not a legacy engine. The chuff actually has a physical cam, and I am going to be putting a 4-chuff cam in this. I talked to my dad about it, and he said that he wants to do the 4-chuff cam because it's a lot more realistic. So that's what's going to happen. Yeah, so I guess I can start getting that open now that the motor seems to be fixed. Although I should probably, like, mount it and make sure that, you know, the thing actually turns the driveline smoothly before I go off and do something completely different. Okay, motor's back together. Let's power it up here. I think it's on. It's really quiet. Oh yeah. You can actually hear the reed switch clicking. That's pretty cool. So I guess all that beeping and stuff that happens is all in the tender with the rail sounds. Because just sitting here, nice and quiet, smooth. Nice. Okay. So I guess I can button up the rest of this, and then I can start working on the cam. Alright, motor's back in, trailing truck's back on. The bracket is removed, so I have actually access to this. And if you haven't seen how this works, down here is a little limit switch, and I will I'll pop it out here for you. That's one of those factory torque snaps. So, little cherry switch. And down below it is a cam. And as the motor rotates, that cam is fixed to the driving wheel. It's actually a split in it. And that rotates. And you can see it's got two lobes. And that's what contacts the limit switch, wherever I put that to. There you go. Contacts this, closes a switch, closes a circuit, and voila, you have chuff. And I believe these are switched to ground too. So pretty easy to duplicate with most methods, or most common practice methods. So what I'm going to do is I'm going to take my X-Acto knife and I'm going to go down there with a flat blade and just try to cut this out. Basically, there's a lot of ways you can get this removed. Because Lionel does this thing where the drivers are captured in the frame, you cannot just remove the this cam. You can't just slide it off. And it doesn't just snap around, or if it does snap around, I haven't figured out an easy way to snap it the other way around so it comes off. So the easy way to do it is just to cut it, or you can also melt it with a soldering iron. Get creative. How do you want to do it? I like using the X-Acto knife because it doesn't completely mutilate it, so I can still take some measurements. But if you've already got a cam that you're going to put in it, then you don't need the measurements, so you can just melt it out. But yeah, I'm going to do that, and I will see you guys when the cam's out. This is the flat blade X-Acto knife I was talking about. So I got through it, so now I got to try and fish it out here. So there's one half. And now I got to figure out how the heck to get to the other half. You guys can't see anything that I'm doing. No, come to this side. Okay, what if I try and roll it over to the other side? I just need to hook it. Alright, hold on, let me play with this for a second, I'll get this out. Got it. So, when these two pieces are together, that's sort of how they look. You can see the two lobes. And the easy way to make a 4-chuff cam is just to make a square, because you just need 4 lobes instead of 2. The big thing that I need to know what diameter shaft Lionel used on these engines, and then I can just put that into my my square cam and call it good. I also need to know the lobe height, and I need to make sure that the lobe height on my square cam matches the lobe height on the 2-chuff cam. That way I'm not causing any premature triggering of the switch or any binding or anything like that. And then I print the square cam in 2 pieces. You'll see that when I actually get around to printing it. I'm just now remembering that I have a 4-chuff cam from the project we don't talk about. That might be the same drive shaft diameter. Let me go see if I can find that real quick. Unfortunately, I think the answer is going to be no. You can see through or you can see some black through the 4-chuff cam in the foreground. So that means that the shaft diameter on these drivers is smaller than the shaft diameter on this, and this is fully tightened down. So there would be no extra clamping or anything from this. So unfortunately, this will not work. Also, if you're wondering what this is the 4-chuff cam that Sunset Third Rail uses on their engines. Usually, on some of their stuff, they have 2 limit switches, so you can switch between 4 and 2 chuffs per revolution at the flick of a switch, because they have 2 reed switches in there, and there's a 2-chuff cam and a 4-chuff cam, and you're just switching between which one of those signals is grounded, or which one of those switches is grounded out, and that's the one that sends the signal back to the tender. So that's what this is. Really nice, pretty part that I really want to find a use for. It may end up getting used in the project we don't talk about, but yeah, I'll find a use for it somewhere. Anyway, back to taking some measurements of this and going to make a 4-chuff cam. Yeah, here you go. This is what I was talking about. It's 2 pieces, just makes a square. Pretty simple. Rounded edges so that it doesn't hook on the limit switch. The only thing I did once this came off the printer was cleaned up the edges. So I put some edge breaks in, which are basically just chamfers. They're on these edges here so that it sits nice and flush against the axle. I cleaned up the interface points as well so that it, actually seats nicely. And then I scored the ID here so that when I glue this to the axle, which I still need to score, it gets a good bite. So, by the way, it's a 5mm axle and a 12mm peak to peak. So cam lobe to cam lobe is 12mm. That's this rev. I'm hoping that it just works first try. If it doesn't, you guys are going to see that happen. And I'll tell you what the actual measurements are later in the video when I redo it. But yeah, this is Rev 1. And when I'm going to glue these in, I'm going to glue them in like this. So I'm going to glue 1/2 in directly on top of the axle. And what this means is that because each one of these corners is your chuff point, that means that the drivers have to be at a 45. So if you don't know, the way that the chuffs are actually generated is when the wheels are turning. Every time the piston down here completes its stroke, it pushes the steam out of the cylinders into the steam chest, and then it is expelled through the smokestack to pull the smoke from the firebox with it and get the smoke out of the engine. So that's why steam engines chuff. So they always chuff at 12, 3, 6, and 9. So yeah, if you're going to just mount it flat like that, you want to make sure that your cam point is on the 45. It'll probably be easier for some of you guys to visualize if I put it like there, and I show you how the cam would sit on the axle. So yeah, so I'm gonna do this off camera because this is kind of finicky, and I will show you guys what it looks like when it's done, and hopefully I don't need to do any shimming on the limit switch or anything like that, and it just kind of works. But it's me, so that's not going to happen. So let's see how many times I have to redo this. So that's the first side in, and I'm just letting the glue set up for a little bit because it's plastic to metal. It takes a second for the glue to cure, and then once it's set up enough that I'm comfortable, rotating it, I'm going to turn it upside down, and we're going to glue on the other side. But seems like the axle shaft is the right diameter, so that's cool. But yeah, let's keep going. All right, I'm going to try and kill like 3 birds with 200 stones here, and take apart this smoke unit. And I want to see if I can figure out, I got a hunch that the batting is just shot. So I want to test my theory here, because I know the fan motor works because you can hear it. It just doesn't make a whole lot of smoke. Oh, yeah. Okay. Yeah. Yeah, I think it's safe to say that might be your problem. Also, this material is interesting. I'm used to like the cotton stuff that they use in the modern smoke units. This is like actual like lantern or candle wick, like in a weave. Um, really interesting. Could I flip this over and probably call it good? Yeah. Am I going to? No, because that feels wrong. And the stuff is not expensive, so I'm just gonna buy some new batting. I am also gonna look at the resistor. I'm gonna ohm this out. I want to see what resistance I get across this. If it's not 8 ohms, I'm gonna buy a new resistor. And honestly, even if it is 8 ohms, I might buy a new resistor so that I can get a new one of these cover things, this wicking material, because that's also pretty charred up. Um, so yeah, let me measure this and see what this is, and I will see if I can find if this is not 8 ohms, then I can put an 8 ohm in it, and we're great. If it is an 8 ohm, then I don't know how much hotter I want to make it, so I don't think I'm going to be putting like a 4 ohm or something in here, because this does usually run in command mode where like you're running max voltage, so 8 ohms is honestly probably more than you need. So anyway, yeah, let me measure this and see what we got. Okay. 8.8 ohms. All right, so it is an 8 ohm. Cool. Still gonna buy a new one because yeah, I want that new wicking material and I want the new batting material. I think the gasket's fine, honestly. It doesn't. I mean, like it's just a paper gasket, but like it seems to be doing the thing, minus the fluid that's clearly on the sealing surface. But whatever. We'll just ignore that. So yeah, cool. Also, if you guys are wondering what this is, because this is just kind of flopping around in here, if I remember correctly, this is the controller for like the semi-smart smoke unit that this thing has. Why it's semi-smart, I've got no idea. All it does is it just continuously blows smoke, and you can buy, I think it's a super chuffer. It's a board that actually like lets you have chuffs using this smoke unit. We're not going to do that. It's just going to be, constant smoke machine. But, which this thing, realistically, once you get it running at a reasonable pace, which this is a fast freight locomotive, once it's running at a reasonable pace, it's just a constant stream anyway. And when it's sitting at idle, it's a constant stream too. So, like, it's really only at slow speed operations that it looks weird. But I don't know how often this is going to be doing that. So, yeah, so I need new batting material, a new resistor, can reuse the gasket, and yeah, I think I'm gonna add those to my cart on Lionel. I might also just order extra traction tires because these traction tires, these are 1-inch traction tires, and they just seem to go on like everything, from like 68-inch to 80-inch drivers. Everything uses a 1-inch traction tire, so I might just order a bunch of those so I have a stock. But yeah, that'll be that. I'm gonna do that, and then I will mess with the other side of this chuff cam. Okay, parts have been ordered for this, so this is just gonna kind of sit like that for a minute. I went ahead and put on the other half of the cam. There's the seam, so I'm just gonna let this sit and set up, and I'm probably just going to leave it overnight, and I will come back to this tomorrow and figure out how my switch engages with it. If I need to shim the switch, I can do that. I can just put little like sheets basically under here just to lift up the switch enough so that when the cam runs underneath, it actually just triggers it right when I want it to. For the K4 that I did, the TMCC K4, I remember I had to switch the sense here. Well, now I'm gonna maybe have to do that anyway because that wire just snapped off. But yeah, it was a normally closed switch, and it was triggering the chuffs not where I wanted. So I went ahead and flipped it on that one. So I'm just gonna quick check the sense of this switch and make sure that it's normally open. So it sends a signal when the switch is closed. But yeah, and then I'm gonna resolder this wire, obviously, and then I'm gonna go to bed because it's late and I'm tired. So I will see you guys hopefully tomorrow when I keep working on this. Curiosity is getting the better of me. I wanna see I wanna see where I'm at here. If I can get it to boot in command mode. Alright, cool. I'm gonna play with this for a second. Okay, I flipped the alligator clip to the other side of the DCDR. And now it boots in command mode. Nice. Okay, let's fire it up. And see how this works. It's not an even chuff. Interesting. Okay. Let me see if I can figure out where that split is, and if that's on the seam, then maybe I'll have to make the cam lobes a little bit tighter. So on this side of the joint, there was a big gap that wasn't there on the other side. And I totally forgot to check that to make sure that they were even. And now I've just filled it with glue on this side, which is the side with the gap. And I've got it clamped together with this contraption. So hopefully that'll fix the inconsistent chuff issue, but I'm just going to let this sit overnight and let that glue harden, because that's under a lot of tension, and if I just let that go before the glue is fully cured, it's just gonna open back up. If it isn't cured by tomorrow, then I'll split open the other side and attempt to re-glue it here. But we're gonna see how this goes first, and hopefully this works. Okay, so I went through and glued both ends, so they're pretty well welded together at this point. So I'm gonna put the reed switch back in, and we're gonna see if that fixes our chuff inconsistency issue. Okay, let's see what this does here. Okay, good. It's still in command mode. Alright, let's see if we got a good chuff. Okay, well, I guess I'm gonna be cutting that out. I'm gonna look at it a little bit closer first, but what's probably gonna end up happening is I'm just gonna cut out that square cam, print another one with a slightly larger inner diameter, so that it's easier to wrap around the axle without it, being misaligned slightly. And then I'm going to use that square cam and glue that on and see if that fixes the problem. But I'm gonna tinker with it for a little bit here and see what I can get to make this work. Okay, I think I got it. Last night I was able to put on the new cam, and it sounded a lot more even. So let's fire it up this morning and see if it still sounds the same. Oh yeah. It's not perfect, but it's a lot closer than it was. If I want to mess around with this more, I might. But like for right now, what I need to do is I just need to pack this thing up because we're moving, and I need the workbench to try and wrap up another project. And then this is going to get moved over to the new apartment, and probably the next time you see it will be with a different backdrop, maybe. Um, but yeah, so that's gonna do it for this engine for right now. So I will see you guys when I'm back working on this thing, probably in a new spot. So just listening to the clicking of the limit switch, I think it's a lot more even now. I can't actually hook up the sounds until my fiance is up, but it sounds a lot more even. So I think that's pretty good. I ended up, I just printed another set, and for some reason, the right hand side cam, or half of the cam that I print, has the same artifacting issue as the first time I did it. But the left hand side one seemed fine, so I guess I have two left hand squares on there, but you know, they're symmetrical anyway, so it doesn't really matter. But I'll see what it sounds like with the rail sounds a little bit later. I think for right now I'm going to take apart the smoke unit and start putting in the new components that I got. I honestly need to do more reading on these smoke units. I know Lionel has they have their traditional fan-driven smoke unit, there's a smart smoke unit and a semi-smart smoke unit. I think that went into these TMCC engines, and I don't know which one's which. This one does have the control board here, so I think this is a semi-smart smoke unit, because it doesn't chuff. It does have, I believe it's different voltage settings depending on what the train's doing, but I'm not sure what makes it smart or semi-smart. So here's the top plate, and I think I showed you guys this before. This is just shot, so I'm going to replace this with a new 8 ohm resistor, and I believe these wicks should fit. Yeah, I can probably trim them down. If you're looking for the part number, 691 res 8 ohm. Pretty simple, and then the sleeve is 610-416-3056. And I think those will fit together, I hope. And then the wick material, this is 691 Smoke P008. And what I'm going to do with this is, I brought up my scissors and now I can't find them. There they are. All I'm going to do is cut this in half, and that should give me about the length that I need. These are really long wicks, and I don't think I need to stuff all of this in there. So if I do need more, I can, I can put more in, but for right now, I'm just going to fold it in half, cut it. Now I got two 6-inch segments. I'm gonna go in here with needle nose pliers and fish all this out. Fiberglass batting. Still drenched in smoke fluid. I don't think I really need to do much cleaning inside of there. Whoops. It actually looks pretty good. And I know the fan works just fine, so that I'm not going to touch. And then when I put my battings in, I just kind of lay it in and try and coil it as best as I can. And stuff it down into the bottom. You don't need to fill the chamber with batting material. It's actually probably not a great thing to have the batting so that it's directly touching the resistor, because the resistors do get very hot. I have a post-war engine, I have a couple post-war engines now actually, that have 3 ohm resistors in them, and those things literally glow red when you're running it in conventional mode. So an 8 ohm resistor running at max voltage all the time, it gets pretty toasty, as evident by, that. So Yeah, I'm gonna desolder these, and I'm going to fish in one of these new resistors after I put the sleeving on it, and then this should, after that, just be ready to go after I prime the smoke unit. So yeah, let me get to desoldering rather this resistor, soldering in a new one, and I'll see you guys when that's done. Here's the old resistor. It's honestly still in decent shape. It could probably be reused. I'll put it in my stash. However, if you're thinking that you may be able to just buy a new sleeve, the answer is you might be able to. I had to cut this one off, and the trick about doing that is when you are cutting it away, you want to make sure that you're not cutting any of these wires, because these windings are, what generate all the heat, and let the smoke fluid vaporize. So you just got to be careful with it. Sometimes it's easier just to buy, replacement 8-ohm resistors. The new ones have more windings. It's a little bit more even heat distribution. It's the same resistance, so it generates the same amount of heat. I just think that I know these work really well. So we'll see. We'll see what one of these does in this smoke unit. But yeah, let me get to putting the new one in. And because I'm me, I want to know what the actual resistance of this new 8-ohm resistor is. Let's see. 8.765. It's getting better the longer I hold it. Okay. Yeah, decent. Okay, let's trim up these leads here. And here's the final configuration. It does fit. And I do think this is pretty well embedded in the batting, which I don't really want, but it's probably fine. It might actually heat up the batting a little bit better. I just don't want to burn the batting again immediately. So last thing I'm going to do here is, while I have the smoke unit open, I'm going to prime it. Usually when you get brand new locomotives, you have to do this, and you just do it through the smokestack. But because I have it open, I can put the smoke fluid directly in the batting. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 14. I wanted to do 15, and I did 16. Whoops. Okay. I'm debating if I want to put some on this. The reason this exists is so that when you add smoke fluid, the smoke fluid gets absorbed into this wick, and it gets heated more evenly all the way around. The reason that Lionel doesn't always recommend doing or using these wicks is they cause the smoke fluid to crystallize sometimes, depending on how hot your smoke unit gets, and that can cause your smoke unit to basically not operate. So I might put a little bit on here. This is actually kind of waxy. It's interesting. It almost feels like it has a coating on it of some kind. But yeah, I'm just gonna put maybe a couple drops on it just to see what it does. Yeah, it is. It's got some sort of coating on it. I'm not sure if you guys can see how the smoke fluid's beaded up on top. Yeah, it's just running off. Interesting. So maybe that's not what it's for. Maybe the video I watched lied. Okay, well now I gotta go wipe all this oil off of me and of the smoke unit, so let me go do that real quick. One other note about smoke units. I usually tell all my friends that when you add smoke fluid, make sure that you don't add it when the smoke unit's hot, because if you drop smoke fluid directly onto a hot resistor, it'll crystallize. Some smoke units you can just put it in when it's hot, and this is the reason. When you add smoke fluid to this, it doesn't hit the resistor. It just goes straight into the batting, and that's totally fine. So if you have a smoke unit where you can see the resistor underneath of it, probably best to let the resistor cool off for a little bit before you add smoke fluid, but if it's something like this, go for it. Just dump it in. Alright, so let's plug in, I believe this is the 3-pin is our fan, and the 2-pin is our power. 2-pin is going to be more of a struggle because it's short. Okay, let's not forget our gasket. They're not really sided. There's cat fur all over this now. Let's get all that off. Thank you, Hazel, for just being all over my workbench last night. Okay. Set that on. Set in a screw. Get one down. I'll find that in a second. Once you get the corners, it's pretty easy, but it's just getting the corners that's usually a pain in the neck. Also, I usually advise against tightening down screws all the way until all of them are in, because you want the board to be able to rotate a little bit, because the clearance holes are slightly bigger than the diameter of the major thread on the screws, which is the outermost diameter of your thread, and that means that there's always a little bit of play in your clearance holes. So the board can shift, and if you tighten down 3 of your screws all the way, and then you go to put in the 4th one and it doesn't fit, that's why. So if you just loosen up the other 3, the 4th one will just drop straight in. Okay, I think that's that for the smoke unit. So let's throw this back up on the test stand, hook up my little ground alligator clip, and let's see how this performs. My plan is to get like a black poster board from Michael's and put it against the back wall here, so when I do my sound demos and I do smoke unit demonstrations, there's actually a black background that you can see the smoke against. But for right now, we're just using my notebook. So let's power this up here. It is eerily quiet when there's no rail sounds involved. 67, fire it up. Fire up the smoke unit. I hear the fan whirring away. Let it heat up a little bit. You can boost it. With TMCC engines, if you press and hold the 9 key, it does what's called a boost for your smoke unit. And basically it just amps up the voltage a little bit to get it hotter faster. So let's check. You can see it's starting to smoke now. Let's check our voltage across this thing. I want to see what we got. It says 0.5 volt. Really? That's all? That is, yeah, that's 0.5 volt. It's smoking pretty good. Oh yeah, that's actually smoking really good. I want to see if I can get my probes on this so that needs to be on a t-shirt. So I can press and hold the 9 key and tell you what the actual what the voltage is that it outputs when you do the boost function. Holy crap, that thing smokes a ton. Yeah, I think that's more what we remember it being. Let's see if I can bite this with an alligator clip. I sure can. Alright, so that's 1. So I'm at
5 volts, like 5.8 to 0.6, or sorry, 5 volts, 0.5 to 0.6 volts. If I hit the 9 and hold the 9 key, it doesn't do anything. Aux 1, 9? It goes up a little bit. It goes up to like 0.65, and then you let it go and it drops back down to 0.6-ish. So gives it a little bit of a boost, I guess. Interesting. Wow, that's actually... my lead is quite warm, just from being on the resistor. That's pretty good. I want to do some more experimentation here, so let's set up my voltmeter here and probe it out. Oh, maybe that's what it means by it's semi-smart. It probably has or no, it doesn't have a thermistor in it. I was just looking at it, but the voltage is getting higher the longer it's running. I just want to know if I step it out here. What does the voltage do? It stays about the same. Yeah, stays about the same. Okay, so maybe it's a semi-smart smoke unit. Oh, that's warm. Whew. Hot, 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 hot. Alright, cool. Well, I guess I can demonstrate while it's up here on the test stand the next problem that we're going to have to deal with, which is, as you can see, it runs forward. But if I put it in reverse, not sure if you could see what just happened. You may have been able to hear it in the smoke unit, but when I put it in reverse and I try and step it out, it shorts the whole thing. And I don't know if that's something that happened as a result of the transformer blowing up earlier or what, but my guess is that one of the triacs on the DCDS, actually I looked up this part number, it's a DCDS, not a DCDR. There's a difference. I don't know what the difference is, but there is one. These have a 6-pin plug in it, and the DCDRs have a 4-pin plug. So my guess is that it has to do with motor feedback. And this probably relies on the magnet wheel, whereas the DCDR relies on back EMF. But no idea. But yeah, so when I try and put this thing in reverse, it doesn't like it. So my guess is there's a bad triac. So I'm going to do some quick reading and see if I can figure out how to diag triacs while they're installed in a system, and see if I can figure out what exactly is going on here. So here's the DCDS. You can see it's got the 6-pin plug. This is the big AC-DC rectifier, and then here are your triacs, which are in an H-bridge configuration. I just did a bunch of research on H-bridges, and these are honestly pretty cool. You can do some pretty insane stuff with an H-bridge. You can also, do some damage with an H-bridge if it's not set up correctly, but I'm going to assume that, Lionel knew that when they designed this stuff and they did it right. But, these components are like over 20 years old at this point, so they do fail. So I wouldn't be surprised if one of these is bad, but I am going to test it first. The other option is the actual motor control signal comes from the R2LC or the R4LC, which is the radio receiver board on the locomotive. However, if there's a bad triac in here, I don't want to cause something to go wrong with the radio receiver board. So if I put a new radio receiver board in here and that gets damaged based on from these triacs, I don't want that to happen. So I'd rather just test these because it's easy first, and then if these are all good, then I'll try switching out the radio receiver board. Getting this out is a little bit of a pain in the neck because I didn't want to cut any zip ties or undo any of the nice wire management that's in that engine. So yeah, a little bit tricky, but we're here now. So I'm going to take off this heat shield. This giant thing is just a heat sink basically. Triacs get really hot when they operate, so you need to, sink them to something so that all the thermal energy can dissipate into the rest of the chassis and doesn't get contained within the triac, because the triac will just fry itself if you don't have some sort of heat sink on it. So yeah, pretty easy to take off. I'm just going to undo this screw and hold this washer, or hold this nut with a screwdriver. And it does look like the triac base is electrically isolated from the thermal or from the heatsink, just based on that like nylon washer there. I'm not 100% sure though. I think usually there's like a thermal paste between the back of these triacs and the heatsink. I don't know if that's non-conductive or not, but yeah, let's take it apart here. Oh yeah, there's actually there's a gasket. How about that? So yeah, these are electrically isolated from the heatsink. Interesting. Okay, noted. So yeah, let me start taking this apart and start diagging the triacs and see if the triacs are good. Here you go with the heatsink off. That's what it looks like. It does have little gasket insulator things on the back of it. This little nylon thing is like melted to the triac, so I'm wondering if this is the one that's cooked. But I do have to desolder these from the circuit in order to test them, so just going to be a lot of little fiddly solder sucking and resoldering and whatnot. But yeah, I'm going to start with this one because this one looks like it's going to be a problem. So let me get this one pulled out and I will show you how to test these. So I think you can actually test those in a circuit, and I'll show you why in a second. I've got my multimeter set to the diode mode, and the way that you test a triac, this is a known good one, is I should be able to go from either pin or either outer pin together. You see I got about 70 on multimeter. Can do that in either direction, and that's fine. I think it's anywhere between like 50 and 70-ish is about where they're supposed to be. And if I go from the center pin to the outer pins, you can see that regardless of what pin I have where, if I have the red pin on the center and I don't touch the leads together, you can see that you get nothing. Outer 70, regardless of polarity. So that's how they're supposed to work. Now up here on our DCDS, this pin, this pin, this pin, this one, 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 this one are triacs. So if I go together on the outer pins, you can see I do get a reading, and I do think it's polar just because of the rest of the circuit. So I get a reading, which is what I want. If I go to this one, I get a reading on the outer pins. I flip polarity. Get like 700. This guy, 650. This guy. You might be able to see the problem here. Let's try flipping that. Yeah, I think that triac is cooked, literally, seeing that that's the one that has the melted nylon washer in it. So yeah, I think that's a proper diag. So I'm going to try and pull this out and see if I can test it here on the bench and confirm that it is in fact bad and it doesn't behave like this one. And then I'm going to see if I can find that part number on DigiKey. It'd be fantastic if this one was just a drop-in replacement for it. I got these for an ACDR that came out of my, I think it's an ACDR. They came out of my Purple Diesel, my TMCC Atlantic Coastline GP7. That board blew up, so I got these to fix that, and I just haven't done that yet. So yeah, let me see if I can extract. I thought it worked for a second there. Let me see if I can extract this this triac, and we'll go from there. Well, that was a fight. Finally got it out. So let's see what this does here on our outers. Flip it around. Yeah, that's cooked. Oh yeah. Yeah, that one's just toast. Okay, let me, I guess, go on DigiKey and see if I can find that part number. I'm sure it's obsolete, but let me see if I can find a replacement, or at least something that's equivalent. Okay, so update. This is a triac, BTA 08-400C, is in fact a 400 volt 8 amp triac made by ST Microelectronics, and the other one is a MOSFET. It's an International Rectifier Series F9540N P-channel 100 volt 23 amp 140 watt MOSFET. Interestingly, Inferion Technologies is marked as the manufacturer. When you go into the datasheet, it actually tells you that that logo is International Rectifier, which makes sense for IR. Speaking of the datasheet, here it is. International Rectifier. IRF 9540N. And then I'm assuming this is lead-free, is what that's supposed to mean. So it gives you all the specs and the response and all that fun stuff. The cool one for me is down here in the date codes. You can see it's got the part number, and then it tells you the assembly lock code as well as how to read the date code. So what I would assume this is lock code 0D51, and the date, knowing that the model was made in I think 2002 or 2002 to 2004, I want to say. It was like somewhere in that range is when the M1 came out. I'm going to guess this is 2002, 19th work week, and then F is the line number. If the line number is P, that means that it is lead-free. So mine is not lead-free, I guess. But yeah, so have to test it a little bit differently than a triac. The datasheet does tell you, which one's your gate, your source, and your drain. But yeah, so still tests bad. It's still all shorted, but at least I know what replacement part to get. And better yet, it's still active, which is amusing. Usually, when I'm looking at these old components, these are usually all obsolete or marked as obsolete, and I have to find some sort of like similar to. I don't have to do that with this, so that's pretty neat. So I'll probably get a couple of these and just keep them in stock. They are not expensive. It's $1.79 per MOSFET. So, oh, you know what? I'm just now remembering. I have a electronics kit that has MOSFETs like this in it. I would be amazed if it had this one specifically, but maybe it has something similar. Let me go look at that real quick. So I do actually have a power MOSFET. It's a IRF 510. And if I look that up on DigiKey, it is a 100 volt, 5.6 amp, which I might be able to make work, 43 watt, which I might be able to make work, but it's an N-channel MOSFET. And the N-channel MOSFET and a P-channel MOSFET are fundamentally different in how they operate, so I cannot use this. So I do actually need to get some of those. And then these guys are transistors. So what I'm going to do is I'm going to clean up a little bit. I have another project that may need electrical components, so I'm going to work on that for a little bit. But rather than putting all this back together and then just having to blow it apart in 2 days when DigiKey ships me the stuff, I'm going to put it in my super high-tech, fancy, anti-static storage container, otherwise known as a cardboard box. And that way I can just keep all the stuff in one place and not have to blow it all apart again when I get the new MOSFET. MOSFETs, I'm curious because I don't think MOSFETs can actually be tested in a circuit. I'm pretty sure I've done that before and they just don't test right. So the datasheet does actually have a desoldering spec that I can use to hopefully make that process a lot easier and not melt the electronics on the inside. I don't think I melted these because it was behaving like this before I took it out of the board. Yeah, so might use that to try to carefully extract these and test them, but that's a lot of work for something that, you know, they're all consistent. The three of them behave the same way, so I would guess that they work. This was the black sheep of the bunch. Didn't quite look like the others, so I think that that's probably a good diag, but I'll get 4 of these at minimum in case the other 3 are bad. But yeah, let me clean this up, and I will see you guys when I have the new MOSFETs.
How's that for lighting? All right, I got parts. These are those MOSFETs that I was showing you guys. So I'm going to crack these open. I'm going to take this out, and I guess I'm gonna, you know, probe this first and make sure this is still functional. Because I don't know why I would get bad components, but Lionel has taught me to not necessarily trust new stuff. Trust but verify, right? So yeah, once I've tested this, I will go ahead and install it in here, and I'm gonna compare the new MOSFET readings with the ones that are currently in it, just make sure they're all doing the same thing. And then we should be good to plug this back into the locomotive and hopefully, you know, test it out in ideally reverse. So theoretically, here's how you test a MOSFET. So if I put my red lead on, I think it's the source, it's the far right pin. You guys can't actually see what I'm doing. Far right pin. And I put my black lead on the gate, which is the center pin. You can see I got nothing on the multimeter. I'm on the little diode mode. If I touch the drain, it puts a negative bias on this the MOSFET because there's a capacitor in there. And now if I touch the center lead, you can see there's a voltage on the meter. So that's nice. They also have something, I think it's called a flyback diode, where if you touch the red lead to the gate and the black lead to the source, we get a diode reading. So that's a good functional MOSFET. A not functional MOSFET, I can't remember if I demonstrated this. If I go gate, source, you can see that it's not happy. That is a direct short. That is what we in the professional business call bad. So yeah, needed to be replaced. So, and that is apparently just a thing that they do. When these fail, they just completely short out, which explains, or would explain, why I was getting a direct short when the engine was going in reverse. So this is probably a MOSFET that controls the reverse. So I'm going to try and extract this nylon insulator. That way I can put it in this guy, and then this guy will go in the what do you call this? The motor control board. Okay. It's in. Not my finest soldering job, but, you know, not terrible. It's good enough.
But yeah, it's behaving the same way that the other ones are behaving, so I think we are good to go. So I'm going to put on the heatsink and the little rubber gasket thing in reverse order. And then we will put this back in the locomotive and see what it does. Alrighty, it's all plugged back in. That was a fight. It's all got the original wire routing, which is nice, but yeah, that was a little bit of a struggle there for a minute. So I'm going to make sure my antenna doesn't accidentally ground something out. Power it up. It didn't immediately short out, so that's good. Engine 67. Alright, I got a cab light and I got a flickering firebox. Okay, I got forward. Hooray. And now the moment of truth. Let's put it in reverse. Hey! Oh, that feels really good. I actually know what I'm doing. Woo! I understand that what I did is like everything pointed to that is the solution, but it still feels good to make the fix, put it in, and see it actually operating. So I guess the next thing to do is put the tender on and see if I've got the cam actually quartered correctly now that I've got two left side or right side or whatever side it is halves in there. Okay. Oh yeah, I forgot how good this thing sounds. It's so nice. Alright, let's see what we got. Ah! Hooray! I love that. Oh yeah. By the way, trivia fact, if you're wondering why it does that weird like skip or that double chuff thing, that's because when you hit certain speed steps, I think there's an extra signal, an extra chuff signal sent to the rail sounds board for some reason. It only happens at certain speed steps. So that's why like you'll be winding up the speed and every now and then you'll hear it like double chuff. I think it's actually kind of neat. I know it's not realistic at all, but it sounds kind of like the wheels are slipping a little bit, and I just think it's a neat effect. It sounds more like wheel slip than actual wheel slip effects, because like with an actual wheel slip effect, you expect to see the wheels slipping, and you don't see that usually unless it's the new triplex from Lionel. But or it's my Reading G3 that just doesn't have traction, or G2 that doesn't have traction tires. But yeah, this you don't expect to see the drivers actually slip when you only hear one extra chuff. So to me it sounds a little bit more realistic. So I like it. Anyway, I guess it's time to put the shell back on and wrap this thing up. I need to remember I have traction tires. They need to go on. I can't forget that again. Traction tires are pretty straightforward. This is a 3/16 hex. I get to actually use my little hex screwdrivers because these are US measurements. You make sure to not drop your screw in there. And then you just pull back the driver a little bit. With segmented drive rods, this is real easy because the whole back section of this rod would just pivot out of the way. And then once you're through the drive or the side rod, it's just an exercise in, trying to get this thing stretched out over the
over the actual driver without twisting it upside down like I feel like I did somewhere. Yeah, absolutely did. Yeah, real simple process, he says, while struggling to put on a traction tire. There we go. And then you can just put your screw back in. Hopefully you guys could see any of what I was just doing. Tighten this down. Give it a good snug so that it doesn't walk itself off as you're running. And new traction tire. I'm just going to do that again on the other side, and this engine will be good to go. Okay, new traction tires are on. And with that, I think this thing's ready to go over to the club layout and start pulling some freight trains. I hope you guys enjoyed this video, and I hope you all learned something. I know I definitely had a good time going through this engine and getting to try and work out all the details and figure out how to fix all the problems that have plagued this engine for literally as long as I can remember. It's very nice to see this engine back at 100% again with fully working smoke, a good 4-chuff cam, good operation going forward and backwards now, which is a new problem that I had to fix. And of course it sounds as good as it always has. So lots of fun, really had a good time going through it. I hope you guys got to learn something about how TMCC works, maybe a little bit about some electronic component repair that you can do on one of your engines if you're having a similar issue. You don't need to buy, an $80 replacement board. If you've got a soldering iron and you're able to read the numbers on the sides of the, or on the fronts of the components, you can just buy a $2 component off DigiKey, and there you go. It saves you, $70 some in electrical components. But yeah. Next time you guys see this engine, it'll be pulling some trains over on the club layout. I'll have a bunch of running shots at the end for that. But if you guys have any questions about anything that I did on this engine or any of the history on it, or if you want to know anything about the TMCC systems that are in it, feel free to drop a comment down below and I'll do my best to answer your question. I'm definitely not an encyclopedia. I don't know everything, but I know a decent amount. So I'll see if I can help you guys out. But yeah, anyway, I hope you enjoyed. I hope you all learned something. I am CW Hollow 1, and have a good day, or maybe good night in your case. See ya.
Pennsylvania 6759, you are looking good outbound.
West side right there.